2. So our second strategy for limit is using a table or a graph. We tried substitution. Now we're going to look at tables and graphs because sometimes, like, there's no way to write this as a function, so you might only have a graph to look at. So what is the limit again? It is a value, a y value, right, that a function approaches as the x value approaches something. Or it could get closer to positive or negative infinity, so meaning like what's the right-sided limit, left-sided limit. So left-handed and right-handed limits are the idea of looking at what happens to a function as you approach a particular value of x from a particular direction. So from the left, you're going to see a little minus sign in the superscript. So I just kind of talked about that in our little review from yesterday. And if it's from the right, there's going to be a little positive superscript. So that's just limit notation and knowing how to read it. So we're going to do a practice of this tomorrow. But for now, if you are looking at a graph, there's a couple things I want to point out. There are filled in circles and there are open circles. If it's an open circle, then the function is not at that point, it's a hole in the graph. And then there's arrows showing that it continues forever in one direction. And our definition of a limit is it's the y value that the sequence or function approaches. So it doesn't actually have to get there as long as it's approaching that value. Like 2.9999 is approaching 3. So even if it never gets to 3, it could approach 3. And for a limit to exist, the left and the right have to approach the same value. So we're going to see how some of these questions play out. So this says, what's the limit of this function over here on the graph at -2 from the right-handed side? So you find -2, right? And you go to the right of that value. So this is the point in question because this is where x is -2 and this is the right-handed limit. So what y value are we approaching? We're approaching a y value of 3. Does everyone see that? The right-handed limit is approaching 3. Now I'm going to look at that same point, -2, but I'm going to approach it from the left-hand side. So it's this point, because as I approach it from the left, I'm getting really close to this circle. So what value am I approaching? I'm approaching 1, even though it's an open circle. So I'm getting really, really close, 0.99999, I'm getting really close to 1. So then it's saying, hey, what's the overall limit at -2? Well, the two ends of the graph are not ever touching the same value. If the right and the left-handed limit don't match each other, then we say that the limit does not exist at that point. So you could have a right-handed and a left-handed limit, but if they don't match each other, then the overall limit does not exist. So this is a different question. This is a limit as x is approaching positive infinity. So that's this side of the graph. What is the y value approaching on that side of the graph? So that's an arrow, right? So the y value is going up, 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 and approaching positive infinity. Right? It keeps getting higher and higher and higher. What's the limit at 3? So find 3 on the x-axis. What y value does the graph approach? What would you say? Yeah, I'd say it's approaching a y value of 2, wouldn't you? And then what about when x is 1? What y value are we approaching? So when x is 1, what y value do you see? So is this any different than when x was 3? See how this was approaching 2? This also approaches 2. So even though it's not a filled in circle, the right and the left-handed lines are getting as close to 2 as you possibly can, and then it's just an open circle at physically 2. So we could get to 1.99999. So we said that the limit is approaching 2, even if it's an open or closed circle. All right, I'd like you to try to answer the two examples down below. See if you can evaluate those two limits. Just using the graph. All right, so when x is at -1, if I'm -1 on the x-axis, what y value does that correspond to? Looks like it corresponds to +6. If I wanted to write that coordinate, it would be -1, 6. So that is the limit. The limit is approaching 6. As I look from the right and I look from the left, that is the point in question that I'm approaching. This one is asking you, what's the limit as x approaches -infinity? There is the end of the graph that's going towards -infinity. It is approaching the horizontal asymptote, right? It'll get really, really, really close to +1, but it will never quite get there, right? So we say that it's approaching +1, even if it only ever gets to 0.99999. So I didn't need to know the equation. From the graph, I could read what the limit was. This is just an extra rule to throw in there, but whenever you have a constant function, it doesn't matter what number x is, the limit will always be the constant y value, right? This is y equals 5. So if the line is always at 5, no matter what x is, the limit will always approach 5. And on the second example, the limit is always going to approach -2, right? Because every single y value is at -2. So it doesn't matter what you approach for x, the y value is always constant. All right, so here is how we can use our table on our calculator to evaluate limits. First, they're just showing you an example of, hey, this was substitution, but this is what it would look like in the table. It says finding a limit from a table is usually quick and easy when technology is available and allowed. Like on the AP exam for calculus, you can only use a calculator on half of it, I think. An algebra is messy. It's a good idea to pull out your trusty calculator and make a table. X approaches a value that's in the domain of the function. It's just substitution. So if you wanted to find the limit, for example, of 9 to the x, you just look at x approaching 2.5, just plug in 2.5. So it says start the table at a value that x approaches at an increment of 0.01 is usually good enough. So we're just going to practice with a table before we have to use it to find kind of an unknown value. So in your y equals menu, put in 9 to the x power. Just make sure you know how to type in a function and get to the table. So we want our table setup to be at 2.5. So that's above the word window. You go second table setup, start at 2.5, and they want you to count by 0.01. So in my y equals menu, I've got 9 to the x. In my table setup, I've got starting at 2.5, counting by 0.01. So that way, when I go to my table, they just wanted you to practice filling in. Look at 2.48, we're at 232.55, 237.72, 243 is my magic answer. 248.4 and 253.92. So did everyone get that table to show up and you can kind of go up and down from the point in question? And we're just kind of proving that, hey, from the left and from the right, we're approaching 243. Both ends of this graph are approaching 243. So substitution is just, hey, the table tells me that if I plug in 2.5, I get 243 as my y value. All right, so scenario 2, this was just, hey, we could plug it in with substitution. The table's just doing substitution for us. Case 2, what if x is approaching a value that's not in the domain, but the values in the neighborhood are in the domain? So this is a trig function. We're going to look at this table. I want you to change your mode to radian mode when you're when you're doing limits with trig functions, make sure that under mode, my calculator is already in radian mode. Make sure radian is highlighted black. And if you're on your home screen, it'll say it right at the top. See what says radian right there by the battery symbol. So once you're in radians, you can go to your y equals menu. We're going to do the sine of 5x over 2x. So when you type it in, the sine of 5x, that should be in a parenthesis itself, the 5x. And then put the denominator in its own parenthesis so that it knows that the 2x is all in the denominator. So it's the sine of 5x divided by 2x. And then go to your table setup. You want to start at 0 this time. 0 is undefined, right? Because 0 in the denominator would be undefined. So go to your table, start at 0, count by 0.01. And you can see that there's an error at 0. But from each side, it's approaching the same value. So what do you think the graph is approaching as the y value? What do you think the answer is to this limit problem? What am I approaching from the left and the right? Yeah, 2.5. 2.499999 is approaching 2.5. So I've got 2.4958, 2.499 error, 2.499 again, and 2.4958. So the error it's approaching is 2.5. So this we could not have done by substitution, right? Because when I plug it in, I just keep getting an error. But if we use our table to slide really close to where we think we are, we end up getting 2.5 exactly. So it says it looks like the y value is getting close to 2.5 as we approach 0 from the left or the right. We will explore this example in greater depth later, but this appears to be a case in which a graph has a whole limit. And this was not factorable, right? So I couldn't just factor and cancel. So this is just a specific example that you'll see a lot as a rule in calculus that you see the 5 halves in the problem. See how 5 over 2 is 2.5? There is a rule that talks about that. All right, so then case number 3 says, what if x is approaching a value that's undefined, and this time we obtain different results from the left and the right? This is one of those, the arms are going in different directions. So let's do this last function on our calculator here. So we're going to plug in x divided by parentheses x minus 2. So make sure you put the denominator in parentheses and get your table set up to start at 2. So start at 2 and count by 0.01. And so when you get to that page, you'll see that, ooh, this is getting really big and negative. This is getting really big and positive. So they're going in different directions. They're approaching different amounts. And there's an error at 2. Everyone get that? Make sure you put your denominator in parentheses. So this was negative 99, negative 199, error. And then this was positive 201, 101. So they're approaching different values from the left and the right. And it says, all right, so as we approach 2 from the left, this would be the left, right? Less than 2 is to the left. More than 2 is to the right. So the y values are going towards negative infinity. And as we go from the right, they're approaching positive infinity. So we'd say the overall limit does not exist. And that's what it would look like on a table. Just like a graph, the two ends are going in different directions, the table's going in 2 different directions. All right, so then I made a typo. It says, look at 2 more examples together. So just cross this one out because it's actually only 1 more example. That's the same as that. All right, so see if you can do this one yourself. See if you can do the, as we approach from the left, what are we approaching? As we approach from the right, what are we approaching? So what's the overall limit? Make sure you put the numerator in parentheses and the denominator in parentheses in your calculator. Let's see here. So I got that from the left, it's going to positive infinity. From the right, it's going to negative infinity. So we say that the overall limit does not exist because they did not match up. So this says, if it's that easy, why can't we do this all the time? Well, because there is a non-calculator part, and sometimes the calculator will give you the wrong answer. So this is just an example of a couple different functions. Dr. Lloyd called them naughty functions, but try sketching the graph. So if you just look at what the sine of 50x looks like, so the sine of 50x, I think if I just do zoom 6, so it's oscillating so much that it's hard to get an appropriate limit because it's oscillating so much. So that one is hard to read. And if you go to your table at like 0, it's hard. Oh, wait a second. Oh, do not put. Well, I'm not sure why we can't just evaluate this one by direct substitution, but because it's oscillating, it doesn't approach a specific value, I guess. I don't spend a lot of time analyzing these trig functions, so let me see what this one looks like. Sine of 50 divided by x. This is the one that as it gets closer to 0, it does some crazy stuff, and you can't divide by 0. So it's hard to say what this graph is actually approaching. In the table, let's see, what would we say it was? Well, this is approaching a big value, almost 1. This is approaching a negative 1. So in between, maybe it's approaching 0 and cutting through the origin again. So I'm not going to be asking you, these types of trig functions anyway. It's just another reason why having some other methods available. It just says, don't worry about these functions. Simply realize there's reasons why we need to find limits by other means. So I don't know if you'll have enough time today to do all 10 of these problems, but maybe at least try like the top 4. It says guided practice part 1, and it says find the limit. You can use substitution or a table or a graph. And it says if the limit doesn't exist, explain why. If you get down all those 4, keep going on, and I'll walk around and help you, and we can start with this next time.